Good day, everyone. This video will talk about the process of solving linear inequalities. And again, we need to connect it into presentation of the solutions into three different forms. So in the previous video, we're able to learn about those three forms. Right now, we're going to combine it with the solving process. But of course, before we can come up with those three different forms, need to make sure that our linear inequality form is already in its proper and correct format. When do we say that our inequality form is already in the proper and correct format? If it's already in this form, it could either be x is greater than a value here, x less than any value, or you could use the other derivations, x is greater than or x less than, and we have the values here. So we need to come up with those given situations before we can come up with a solution set, the graph, and interval notation. So let's start with number one. In number one, we are going to divide both sides by 2 because we need to come up with an expression with x only. And since 2 and x are separated in multiplication, we need to divide both sides by 2. If we have properties of equality when we talk about linear equations in one variable, we also have properties of inequality. And the properties of inequality is more or less similar to the properties of equations. But the only change is that when we divide or multiply both sides by a negative number. In this case, our divisor is a positive value. Even if our numerator here is negative, it will not really affect the inequality sign because our denominator or our divisor here is a positive value. So when we try to simplify this, we have here x. This one is still negative, is now negative 2, and it's still greater than. Okay, because again the divisor or denominator we have here is still a positive number. Only if our divisor or denominator is a negative value or our factor is a negative value, then there might be a change in an inequality symbol. So that is actually to be covered by item number 3. In our item number 1, it stays as it is. Another proof for that this linear inequality form in number 1 is already correct is if we're going to pick a value in this linear inequality form and substitute it in the given inequality, and if the inequality still holds, that means our result or our solution is correct. Let's pick a value here. Let's try negative 1 because negative 1 is greater than negative 2. Any value of x that is greater than negative 2. So if this is negative 1, 2 times negative 1, that's negative 2. The other side is still negative 4. And then we answer the question, is negative 2 greater than negative 4? The answer is yes, and is definitely this is already acceptable to be true. You could use negative 1 here because negative 1 is greater than negative 2. But my best advice is to use a value that if to be substituted, there is a clear result to any expression. And that value is 0. If and only if 0 is part of the inequality form. Here, 0 is part of this inequality form because 0 is greater than negative 2. So if we are going to substitute here 0, 2 times 0 is 0, the other side is negative 4, it's easier to look at than this because some of us will also get confused if we have this expression. But if we have this expression, 0 greater than negative 4, that is correct, and that proves further that this is correct. This is acceptable. Now that we are now sure with this, upon substituting two of the possible values, by the way, you could substitute any value that you want, but two would already suffice as one. After this is the time that we could come up with our solution set, our graph, and our interval notation. It would be very useless if we are going to start with solution set, graph, and interval notation if we have not if we have not reassured ourselves that this is really the correct linear inequality form. But since this is, let's try to come up with a solution set. If you can still remember, our solution set is a set builder notation form. So this is x because that's x is such that you copy the statement x is greater than negative 2. Close it. That's your solution set. When we graph, our graph extends at both sides, negative infinity and positive infinity. When we graph, we pick our starting point. Our starting point is not negative 4. I need to correct this one. You repeat this one. It's not negative 4. In a previous examples in the previous practice exercises, since our given are already in forms of this one, so our starting point are the values given here. But since our given in number one is not yet in x, this is not our starting point. Where do we depend on it? We depend our graph here. And our starting point is the value here, which is actually negative 2, not negative 4. So our negative 2 is in the middle, right? Because our graph is based on the linear inequality form, not necessarily on the given. But these are the connection. Our graph is based on a linear inequality form, not necessarily the given, but our linear inequality form is still based on the given. So nevertheless, it will affect one another. So let's continue doing this graph. It goes to the right. By the way, let me connect this first. So it goes to the right. So everything on the right of negative 2, because this is where we can see negative 1, 0, the things that we have substituted here. So everything here. And then again, put an arrowhead to denote that it continues, so on. And finally, decide whether negative 2 is included or not. Look at the symbol. Since is no equality here, then definitely our negative 2, our starting point, is not included. So we use an open circle. Let me remove the shade here. Circular figure, not circle. It's not circle. Circular figure. And then we include a parenthesis to complete it and to help us make our interval notation easier to be understood. Now that we have this, our interval notation is based here. The leftmost value is negative 2. The rightmost value is positive infinity. Separate them by a comma and complete with the close and open notations. The close here since we use parentheses, let's use here parentheses. And infinity, even if it's included, as I have mentioned in the previous video, infinity will stay open. It stays open. So this is our complete three forms for the linear inequality form in item number one. But these are all again referred here. So we need to come up with this correct form first. Let's go to number two. In number two, the terms are separated by addition. So we cannot say we will divide both sides, okay? Earlier, we divide both sides by 2 because the operation separating 2 and x is multiplication. So we do the reverse property, the division property of inequality. Here, since the 3 here is a positive value, we need to subtract using the subtraction property of inequality. It tells us that if this will become 0, the inequality will remain as it is. 8 minus 3 is 5. If you're not convinced with that, try to pick a value less than or equal to 5. You may pick 5 because we have your equality. Tama? Equal to 5. Let's pick 5. 5 plus 3 is 8. Is 8 is 8 less than or equal to 8? It's not less than, but it's equal. We have an equal here. This means this is acceptable because 8 is less than or equal to 8. This means that this linear inequality form is correct, and we are now ready to give the solution set, the graph, or the interval notation. If you are not convinced with 5, you may use 4, you may use 1, but of course, you may use my best advice, 0. Again, 0 is the best advice because when you add 0 here, 0 plus 3, you will come up with 3 less than equal to 8. Is 3 less than or equal to 8? Yes, because 3 is less than 8. This proves further that this is correct. Now that we have that, let's come up with our solution set. Our solution set is a set of x containing the linear inequality form. Okay. And then we go to the graph. Our graph will then again be referred n- on the linear inequality form, not the given equation. So we have here, so we have negative infinity, positive infinity. It's centered at not 8, not 8, because 8 here is not, this expression here with 8 on this side is not yet the proper linear inequality form. This is the proper one. So it's not 8, it should be positive 5. It goes to the left as the linear inequality symbol points towards the left. Shade here, arrowhead, arrowhead to make it better, right? And then, since we have an equal symbol here based on our given, we include 5 by placing a shaded circular figure and a bracket pointing on that direction. And finally, for our interval notation, shall be based on this. Leftmost value is negative infinity. Rightmost value until here is 5, separate by a comma. Infinity is always open, but 5 here uses bracket. So it looks like that. Okay, so continue the same process for number 3. But here in number 3, there might be a change. Let's look at this one. Here, do not say, I will add 2 because the sign here is minus. So operation separating is negative, so I will add 2. If you will add 2 here, this will not be removed. It will just increase into 4 and then so on and so forth. So instead of adding by looking in this symbol, look at the sign of 2 because that is what we're going to remove here. The sign of 2 is positive 2. So in this case, we are going to subtract 2 both sides. 2 minus 2 is 0. We are left now with negative x is greater than 3 minus 2, which is positive 1. Do not jump into conclusions that you can now make your um, solution set, graph, interval notation out from this because we need to come up with an expression wherein it's just x, not negative x. So how do we make it positive x? We may divide both sides by a negative value. So when you remove that, it becomes x. The other side becomes negative 1. I'm pausing for a while because this is what there is a point that I need to emphasize here. Earlier in number 1, we divided both sides by a positive number. Our divisor or denominator is a positive number. Division property of equality tells us that the sign remains the same. But in number 3, our denominator here or our divisor is a negative number. The division property of inequality for negative quantities tells us that if the denominator or the divisor in a division process is a negative value, we need to interchange the sign. It should be x is less than negative 1. Let us try to consider that you have not interchanged it. Let's just say you have not interchanged it. Do not jump into conclusions that you could already make your solution set, your graph interval notation. Again, always do the checking. Let us take a number greater than negative 1. So 0. Let's try to use 0 because 0 is greater than negative 1. When we substitute 0 here, 2 minus 0, 2 greater than 3. Is 2 greater than 3? No. This means that it should really be interchanged. It should not be retained because the sign here is negative. Let's try to pick another value. Let's use 10, for instance, 10, because 10 is greater than negative 1. 2 minus 10 is negative 8. Is it greater than 3? Again, no. That is a further proof that it should really be interchanged and not this one. So again, I'm going to interchange this now. But still, let us pick a value less than negative 1, lower than negative 1. Let's try negative 2. Substitute here. 2 minus negative 2, question mark. This is checking, by the way. 3. Double negative property tells us to add them. 2 plus 2, question mark 3. 2 plus 2 is 4. Is it greater than 3? The answer is yes. This is again another support that it should really be interchanged. So there is um, so there is a unique process here when we are going to divide our linear inequality by a negative quantity. It should be interchanged. If from greater than, it should become less than. From less than, it should become greater than. Even those with equal notations, less than or equal should become greater than or equal, and the other way around as well. Now that we are sure with this is the time that we could graph, so give the solution set and indicate the interval notation. As for the solution set, as easy as placing it in a set builder notation, x such that x is less than negative 1. But for the graph, another point here, let me just draw here an arrowhead. It should extend to both infinities. When we are going to graph, okay, earlier, greater than, so we look at the symbol. Here, less than equal as an equal symbol. Here, take note that from the given, it was greater than, and from the end, the solution now becomes less than. Our graph is the graph of the solutions, not the graph of the given. Again, our graph is the graph for the solutions and not the graph for the given. In short, our graph should depend on this, not the given. The given is only used for the checking and for getting the solution. Okay? So, looking at this, we start with negative 1, and instead of greater than going to the right based on the given, it should be referred on the solution here, which is less than going to the left. Because this is where you would see negative 2, which actually made the inequality true, or the given expression true. So we have here these values here. Okay, arrowhead still. And then to complete that, let's come up with our interval notation. Based on this, leftmost value, negative infinity, rightmost value, we haven't completed our graph pala. Let's complete our graph first. After shading this, let's try to determine if negative 1 is included or not. Since there is no equality here, this means negative 1 is open circle, and this should be parenthesis. And to complete our graph, pardon for that. So let's proceed now. Go back to interval notation. Leftmost value, negative infinity. Rightmost value, let's try to use color blue. Leftmost value is negative infinity. Rightmost value is negative 1, separate by a comma. Infinity is always open. Here is also open. So this is the interval notation based on the graph. The graph is based on the linear inequality form, as well as the solution set is based on the linear inequality form, which is actually the linear inequality form is now based on the processes from the given. Yeah. So those are the intersections and the connections between the forms and the solutions. So this could actually represent a solution, solution, and solution. All of them are acceptable. So this is how we express our uh, forms for the solutions out from the different application properties of equality. We still have one more practice exercise, one more video for this activity, for this concern, which would actually talk about more processes that needs to be done to come up with the proper linear equality form, and then chain reaction to the solution set, graph, and interval notation. Please keep on practicing, keep on looking for other problems to try so that you could actually master and improve your speed. Thank you very much. See you soon.